Well, hello everybody, and it's great to have you at Chem. So, we are in our unit on acids and bases and titration, and let us take a look at what's going on here. Consider a 0.25 molar solution of HI. We know what HI is, right? That is hydroiodic acid, and we've memorized it as one of our strong acids, so we know that's a strong acid. What are the hydronium concentration and the pH of this solution? Okay, let us hit some notes, all right? Acids and bases, and let's do a quick review. We talked about definitions, right? We talked about two, the Arrhenius, which has to do with increasing hydronium concentration or increasing hydroxide concentration. Then we talked about Lowry-Bronsted. Acids are proton donors, and bases are proton acceptors. We did talk about strong acids and strong bases, right? And the strong acids are HCl, HI, HBr, H what? NO3, HClO3, HClO4, and H2SO4, right? And all other acids are what? Weak acids, right? Weak acids, meaning they form an equilibrium between their molecule and the ions. These break completely, if I react them with water, they break completely one-way direction to hydronium and the halogen or the oxyanion, right? So those are my strong acids, strong bases. And then we talked over here about autoionization of water. We said Kw is equal to concentration of hydronium times the concentration of hydroxide, and that's equal to 1.0 times 10 to the minus 14th at 25 degrees Celsius. And we said that, hey, for any solution, any aqueous solution, the concentration of hydronium times the concentration of hydroxide equals that 1.0 times 10 to the minus 14th. So if I know one of these, I can figure out the other. And then we said, hey, we can also talk about pH, and that pH is equal to the negative log of my hydronium concentration, which means that my hydronium concentration is equal to 10 to the negative pH. And we talked about POH equal negative log of my hydroxide concentration, meaning my hydroxide concentration is equal to 10 to the negative POH, right? And then we talked about acids or acidity. An acidic solution is what? An acidic solution is one where my hydronium concentration is greater than 1.0 times 10 to the minus 7th molar. And that would mean my pH is less than 7, right? And if it's basic, then my hydroxide concentration is greater than 1.0 times 10 to the minus 7th, which means that my POH is less than 7, which means up here that my POH is greater than 7, okay? And that would also mean here that my pH is greater than 7 when I have a basic solution. And neutral, when I have something that's neutral, what is it? That means my hydroxide concentration equals my hydronium concentration, which means if that is at 25C, it's equal to 1.0 times 10 to the minus 7th, which means my pH equals my POH, which is equal to 7. So that's what we've talked about so far. Now, we want to add something here, right? We're going to come down here and say, how do I figure out, and this is really coming out of our pH, right? How do I figure out the pH of strong acids? Well, it's really quite simple, because for my strong acids, with the exception of sulfuric acid, okay, this one's a little different, but with the others, they're all what we call monoprotic. So we're going to talk about monoprotic. That means one proton. And so those are all my HCl, HI, when I have one H on them. These are all monoprotic, and here's the way you get the pH for a monoprotic strong acid. The concentration of my hydronium equals the concentration of my strong acid. Now, let's take a look and see why that is. Let's take HCl plus my water, one-way arrow, right? I get hydronium plus chloride. Well, what do you notice about the coefficients? They're all ones. So if I have 1 mole of HCl, I have 1 mole of hydronium, and it's all made. All of this chloride, hydrochloric acid, goes to form chloride and hydronium. So I have a 1-to-1 ratio, which means that my concentration of my hydronium equals the concentration of my strong acid. Then what do I do? So step 1, concentration of hydronium equals concentration of my strong acid. Beautiful. Step 2, pH equals a negative log of my hydronium concentration. That is all there is to it. Let's do it. Hey, I was a poet, didn't know it, but my feet show it. Why? Because they're Longfellows. Yes, good. My strong acid, HI, right? So my concentration of HI equals 0.25 molar. So that means what? The concentration of my hydronium equals 0.25 molar. So my pH is equal to the negative log of 0.25. Woohoo! You ready? Handy dandy calculator, 0.25. I am going to take the log of that and the negative log of that, and I get 0. Okay, I have 2 sig figs, so what does that mean? I have 2 decimals in my pH. Wow, pH is very, very small, meaning this is what? Acidic. Very acidic, right? It can burn through my clothes. Got it? Piece of cake. You guys do this one. Well, this should be easy, right? I have a strong acid, right? HCl. My hydronium concentration should equal my HCl concentration, which is equal to 4.75. Good, molar. So I'm going to take then, my pH is going to be equal to the negative log of 4.75. And my answer is 4.75 log negative 0.3 sig figs. So I need 3 decimals. 677. That's my pH. Whoa, 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 whoa. Look at that. Are you telling me, Mr. Smith, that I can have a negative pH? Yes. Yes, I'm telling you that. Yes, you can have a negative pH if you have a great enough hydronium concentration. You sure we did this right? Let's try it. 4.75 log. That's 0.676 negative. Negative 0.6766. Yes, that's the right answer. That is a negative pH. Woohoo! Got it? By the way, what's the pOH here? Well, the pOH would be what? 14.677. Wow! You mean I can have a pOH greater than 14? Yes, I can, and I do, and it's right here. C. C with your big eyes, right? Yay! Little bit of hair, and you can see that that is bigger than 14. Moving on. I have 0.125 molar sodium hydroxide. What is sodium hydroxide? That is a yoink, 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 yoink. Na, 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 na. pH of a what? Strong base. We want to talk about pH of strong bases. What's the process? Well, remember my strong bases are really my metallic hydroxides. And remember, it could be MOH or it could be MOH2, or sometimes it could be MOH3, where that's M is just a metal, right? Or I can also, this is also a strong base, right? Those are all strong bases. And in fact, the only weak base we care about is what? That's the only weak base that we care about right now. Well, let's talk about how do we do the pH. Well, my hydroxide concentration is going to be equal to, I really need to get it from what? Stoichiometry. I need to get it from stoichiometry and the strong base. And what do I mean by that? If I have NaOH, it's going to break into Na plus OH minus, right? And so I have a 1-to-1, and in that case, my hydroxide concentration equals my sodium hydroxide concentration. But what if I have barium hydroxide? Barium hydroxide will dissolve into barium 2 plus 2 hydroxides, right? So that means for every one of these, I have 2 of these. So that means my hydroxide concentration is equal to 2 times my barium hydroxide concentration. Got it? Mole ratio 2-to-1. Barium hydroxide, moles of barium hydroxide, times 2 moles of hydroxide per 1 mole of barium hydroxide. Yes, that's the way we do that. Play the guitar on the MTV. Yes, there we go. It's a 2-to-1 and so forth. So make sure, first of all, the first thing we want to do is get your hydroxide solution using stoichiometry, and then after that to what? POH equals negative log of hydroxide, and then 3 is what? pH equals 14 minus POH. So those are the 3 steps we use in determining the pH or POH of a strong base. Strong base, here we go. First thing I have to look at, NaOH goes to Na plus OH minus. What's my ratio? 1-to-1. So that means my OH concentration equals my sodium hydroxide concentration, which equals 0.125. POH, negative log of my hydroxide concentration, so 0.125 log negative, and it looks to me like it's a 0.90308. So pH is equal to that plus 14, and it looks to me like it's a 13 point, how many sig figs? I have 3 sigs. That means I have to have 3 decimals, 0.97. 3 sig figs in my number, 3 decimals in my answer, 13.097. Wow, that's a big pH, so that is basic. Cool? Last one. Here you go. Show me what you got. First thing I want to look at is my barium hydroxide, right? Barium is going to go in forming barium 2 plus 2 hydroxides. It's a 1-to-2 ratio. That means my hydroxide concentration is 2 times my barium hydroxide concentration. So this is 0.875 molar times 2. Okay, so 0.875 times 2. 1.75 molar hydroxide. Then what? POH equals negative log of 1.75. Take 1.75, and it looks to me like this is going to be a negative 0.24303. So that means my pH is equal to 14.24. How many sig figs? I have 3 sig figs. That means I need 3 decimals. Zoink! Very big pH. That means this is basic. Woohoo! Hey, I like pH and POH. That's a lot of fun and good stuff. Well, that'll do it for us today. We have, I think, one more day of lectures here on acid bases. We'll talk about titration next time. Enjoy. If you have questions, please let me know. Bye.